Okay, so buckling the sides and the edges of each part. This is silicon metal. It's bearing nickel neodymium alongside the edge, and I have it in temporary setting. So for the hole before riveting is bending deformation and shaping the quarter segment. The winding coils will be localized there. I will also wrap the winding coil around the edges, move them up in a linear motion and stop them there. Move it up in a linear motion and stop them there. I will not cross the lines here. I will wind it here, and I will wind it here and here. And between the tooths, the horns, I will wind it between the horns and wind it between the horns. I have applied one here. I picked one for the bowl bearing bracket. It has a few layers on it. I want to keep it thin and not heavy at all. So, therefore, the permanent magnets align all within the system, all around the unit, around the edges. So at the hollow, I'm going to add the rotary for it, and the propeller, which should be synchronous induction, an induction propeller. That should rotate around, and it should be bearing a coil, propellers, and should synchronize the coils along the side. So once it does that, it causes magnetism. Causes the current to transform like a voltage transformer, and that will send the lindinary motion within the permanent magnets to move the permanent magnets from the housing area, which will cause it to move away from its gravitational mass, the inertial mass, as long as the winding energy by the solenoid going upward. So binding these two together with the coil, and these two together with the coil, so that the linear motion will be this way. So while it forces, it will vibrate or even move the electrical energy dust. So every area of a straight area will be localized on the coil, will be bearing on there, and that will cause it to move upward there. Now the float from this way, forward or back, is to use the winding coil to move forward or back. Being diamagnetic, of course, because the diamagnetic will cause the magnets to move this way or this way, depending on the winding energy. The winding energy moves this way and this way, will cause the magnets to move up away from the magnet field. So that's how that works for this part. Then after that's done, before that's done, I must overlay this part with the piezo buzzer, quartz crystal. So I can get quartz crystal and to spread it alongside the exterior. And that's going to be a little bit hard when I get electrocuted. So I have to wear gloves and a rubber handle to the device that I'm using to scrape it on. So once I apply it to here and brush it on, when it's solvent, I can use the paintbrush to brush it on a small paintbrush or brush the quartz crystal and then let it cure. Once it cures, then I can add the bus as far as a rod into it, a metallic rod, and bust that metallic rod to a place where I'm going to be placing encoder as far as a connection to a pin input, a pin output, input connection, basic for audio driver, to drive the plasma to strike against the surfaces. How a piezo buzzer works is it's coated with quartz crystal, and inside of the quartz crystal there is an ion conductor electrode, and that receives a charge and exerts to a spark gap to jump against the surfaces of the other conductor, and that forces the plasma to exert and vibrate the metal. Because of the tensile areas, the thinness of it causes the vibrate to rapidly deform it. Acoustics, that's how the piezo buzzer works. So I'm going to be doing it sort of like that. And that's going to assist me with different modules. So that's going to be a horn for different modules. Connections to different electronic circuits. For tactile sensory, for leading sensories, and many other things. So that's on in addition to the modulated circuit. I do have a flexible PCB board, and that shall be either before or thereafter. So I'm going through a little struggle with trying to figure out if I'm going to put the PCB board on the inside. So I'll probably put it on the inside and just leave this side for the piezo electrocution. And therefore, I can follow up on the rubber and the as far as PVC jelly, rubber, very soft suction cups to couple to the unit. So the shape of the suction cup will be according to the metric range. So my name is Jermaine Morton. Goodbye. Okay, apply the mounts for the back. Remember that the structure has to be redone again, so I have to add the springs as far as the dampers, rubber dampers for the bolts. This is supposed to pan. This is supposed to actually vibrate when I do the piezoelectric effect, because the idea is to, when I use the winding coil, is to vibrate the eddy currents out from the system or back to the system, to vibrate it as if the tractor beam the eddy currents back and forth, and to cause the acoustic radiation pressure to levitate the electrostatic, or the tractor, the electrostatic, against the inertial mass or gravity or weight of gravity. So this is the armor frame. This is the frontal part of the unit. I have applied for the armature bearings for the ball bearings to rotate in the shaft area. Here I have to apply large ones for to move the binocular eyes lenses, where even though the overshield, the overface plate, is going to represent the same structure of the faceplate of the Mark 42 unit. However, this is one of the initial problems. It's not a problem, it's really solvable as far as cutting right across and causing the frontal to lay back or to overlay to flap over. I don't think that would be necessary in this segment to get it just a lift. So, trying to get movie accurate mechatronic ability, but I think that if I rest on this part, it will enable me more better. It would actually, I'll get to the point faster. So, like I said, the piezo, I have to apply the thermal melt of the piezo quartz crystal actually, and brush it onto the surfaces. However, I still have to use the metallic rod for the bus, and I still have to use a ceramic set dry, and to cover the piezo. Once the piezo is applied, as far as the quartz crystal energy cell, to be rubbed all over the frontal part of the unit, so that will enable the bending deformation and electrical energy through triplets to vibrational bending deformation of the piezoelectricity. It will exert the electrical energy from the quartz crystal. So I'm going to put a fine layer of a brush of the thermal melt over this housing, and this should function, operate as the initial the described device. I still have to make modifications on here. The magnets are stuck in here. Remember, there's nickel neodymium right here. That's nickel neodymium. They are all aligned to the entire structure of the surface around the base of the commuter. This is the commuter, and it's to communicate with the cage, armature, or whatever is in the center of the vector, which should have electrical winding energy, exhibiting permanent magnets alongside, while the winding coil is going to be looped through these teeth right here, these horns. So that's going to add there, and also linear motoring also. So that will act as a Hall effect. So when I'm using a synchronous induction pancake motor, pancake propeller, it would rotate around, synchronize the other coils that are alongside the surfaces, and that should add more voltage. However, I got buzzers for cell phone buzzers, and that should give me the bending deformation with a fine thin line of a thin a layer of quartz crystal. And I think that I should embed the cell phone vibrators. I have cell phone vibrators, I have many of them, and these are micro cell phone vibrators. They're pancake size, and they will vibrate the piezo and cause electrical energy to discharge. So if I did not want to use the capacitors, then I'm going to add to it, but I'm still going to do that. That'll create more ions I need in order to get this to levitate as a fly. So this is my Mark 42 faceplate coming into play.